Hello and welcome to BG Electrical's Introduction to Wiring Regulations 18th edition. BG Electrical was established in 1952. Back then, it was better known as British General Electrical. Since then, BG has seen 5 editions of the regulations published and watched how British wiring has changed dramatically over the decades. In this video, we will go through all the key regulatory changes and recommendations you need to know and work with as of January 1st, 2019. In the 18th edition, the major areas of change concern arc fault detection devices and surge protection devices. As well as arc detection and surge protection, we will look at changes concerning consumer units and electric vehicle charging, and what this means for the future of Britain's electrical industry. We will go through what these changes mean and how it affects new homes. Before we begin, here's an interesting fact. Did you know, in the early days of what was known as the electrification of Britain, each major city and industrial area ran off their own electrical and wiring regulations for the region? Something that people don't realise is that electricity in British homes is still a relatively new part of our history. Electricity was a new utility in the late 19th century, which was not accessible to everyone. In fact, the earliest customers would have been factories and manufacturing facilities. This electricity would come from local power plants, and they began supplying homes, initially those of the wealthy and the aristocracy. Each region would have their own sockets and wiring rules. This meant for appliance manufacturers, their products could only be sold, for the most part, locally. A vacuum cleaner made in Birmingham could not fit into a socket in Manchester, not without special adapters. If it could, there was a chance it would still be very unsafe, as the power source would run off different amperage. It isn't until 1934 British sockets and the electrical industry as a whole became unified. Even then, just like indoor plumbing, it would be some time before electricity would be common in British homes. So, let's get started with arc fault detection devices. But first, what is an arc fault? An arc fault is an unintentional arcing condition within a circuit which cannot be detected by fuses, circuit breakers, or by residual current devices. This arc creates high-intensity heat, which can lead to an electrical fire. This can be a break or a loose connection in a single conductor. Now, when a current flows through a damaged cable, the damaged area can cause a noticeable reduction in that flow. This reduction causes the point to heat up. Temperatures over 1,250 degrees Celsius can cause the cable's copper and insulation to carbonize. Now this would depend on current flow. This forms an arcing condition where a stable arc can form and heat up to 6,000 degrees Celsius. Now, these arcs can occur for milliseconds, but it is enough to cause an electrical fire. These arcs can occur naturally in homes. Something as simple as trapping cables indoors or crushing cables can cause arcing conditions. Piercing the cable installation is another common cause. This is how rodents such as mice and rats pose a significant health risk to homes besides hygiene. Another common cause of arcing is loose terminals or the deterioration of installations. An arc fault detection device, or AFDD, monitors and analyzes the patterns in electrical currents and voltage waveforms. Analyzing the current strength, arc waveform and the level compared to the background noise. These patterns are non-predictable but persistent and can cause an electrical fire. When the device detects all of these parameters in an unusual pattern, it trips and isolates the circuit. An arc fault detection device can work quickly and effectively in isolating dangerous arcs, and can work alongside a circuit breaker or a residual current breaker with overload protection. Now you know what arcing is and how you can detect and isolate them. Where do you require an arc fault detection device? In the 18th edition, it only recommends the use of an arc fault detection device under the new regulation clause 421.1.7. which complies with BS EN 62606. It recommends the use of these devices in premises with sleeping accommodation. This could be homes, apartment blocks, hotels, and similar buildings. Locations where there is a risk of fire due to the materials stored or the nature of the premises, such as barns or woodworking shops or warehouses storing combustible materials such as gas canisters. Buildings such as high-rise blocks, which can be classed as fire-propagating structures, are also recommended. The clause also recommends that arc fault detection devices be used in buildings of immense cultural value or risks the loss of irreplaceable goods. This could refer to a museum, an art gallery, or a historical building. Again, the use of arc fault detection devices are only a recommendation. With the rollout of the 18th edition of wiring regulations, surge protection plays a major role in this latest update. But first, what is surge? Surge, also known as transient overvoltage, is when there is a sudden rise in excessive voltage. This can damage the electrical equipment and installations within a circuit and cause an electrical fire. Power surges, or transient voltage, is caused by a number of situations. One cause is lightning striking near your property and causing an excessive voltage to flood your circuit. This would be an extreme example, but also one of the most dangerous. Another could be a power plant turning on its generator and causing an excess of starting current. A surge protection device, or SPD, are designed to limit transient overvoltage in these situations. What these devices would do is to drive this surge current to earth in a very short time. That said, a surge protection device is not designed to be continually exposed to permanent overvoltage. Once activated, the unit is tripped and cannot protect the installation again. Without being replaced, if overvoltage occurs again, there is a risk of damage to the consumer unit or human life. An SPD should be protected against short circuits to ensure the safety of the electrical installation. When the 18th edition comes into effect on the 1st of January 2019, it will be required that new building projects include surge protection, as well as in the case of reworking a property's wiring. As well as domestic installations, this would apply to properties that have sleeping accommodations, such as hotels. According to Regulations 443.3, surge protection is required where the resulting overvoltage results in serious injury or the loss of human life, can cause the interruption or damage to public services, causes damage to properties of cultural value. This can apply to museums and heritage centres, can interrupt commercial or industrial activity, or affects a large number of co-located individuals. The regulations will make it a requirement that surge protection is used in domestic installations. However, one situation where surge protection is not required would be if a risk assessment is conducted, which looks at the calculated risk level of a property, and it demonstrates that the property does not pose a substantial risk of overvoltage. The key feature is the geography of the property and the lightning flash density of the location. If the result of the risk assessment demonstrates that there is no substantial risk of overvoltage, a surge protection device would not be required. Now, there is a clear theme behind these two changes in the upcoming 18th edition. In recent years, government fire statistics have seen that there's been almost 8,000 fires each year in England that originated from a property's electrical distribution system. This number appeared in 2011 and has remained largely stable since. Hence why these major areas of change in the new 18th edition are made to address these statistics. Section 443, which concerns the use of surge protection, has been redrafted to protect the British public from the threat of transient voltage and the potential fire risk it presents. The addition of 421.7, which discusses the use of arc fault detection devices, is another regulation to address this worrying trend of electrical fires. While only a recommendation, it does recognise the potential an arc fault detection device can offer to the British public. Regulation 422.1.1 has also been redrafted to take into account the requirements of the European construction regulations. These changes to surge and arc protection follow the recent amendment to consumer units, which have been changed quite a lot in recent years. Did you know, up until the 1980s, fuse boxes and consumer units were constructed with wood? This is not that long ago. It was only in the 1980s it became a requirement that consumer units couldn't be made out of wood. In fact, quite a number of British homes can still be found with wooden fuse boxes. To a certain type of electrician and installer, this can be a very interesting piece of Britain's electrical history. But for most electricians, it's just worrying to see a building's electrical supply going through a wooden board. These changes in the 18th edition are following the recent amendment to the 17th edition about consumer units. As of 2016, it became a requirement for new homes and in rewiring projects to install consumer units made with non-combustible metals. Previously, consumer units could be constructed with plastics. However, this amendment came about just like the changes to surge protection and the addition of arc fault detection devices. Looking at the trend in electrical fires, it was discovered that plastic consumer units provided little protection when a fire breaks out. A number of investigations conducted by the fire brigade found invariably that these fires were caused as a result of poor electrical connections due to poor workmanship or from a lack of maintenance. It has been observed that plastic consumer units in the case of a fire did not resist the fire. They would melt the thermoplastic body over time, and when the unit collapsed, allowed the fire to spread. In the same situation with a metal consumer unit, it offers better resistance to the fire and maintained its form containing the fire. It could self-extinguish and eventually put it out. Nevertheless, a consumer unit constructed with non-combustible metals would contain the fire and make it easier for firefighters or a member of the public to extinguish. Electric cars and other electric vehicles are becoming more and more common on British roads and will play a larger role in how Britons travel around in the future. However, we might be wrong. People have been wrong before, very wrong. Back when BG Electrical was first established, there have been plenty of predictions of how people would travel around in the future. From airships to underground pneumatic tubes, people had very different ideas on the future of transport back in the day. Did you know, in 1951, 1 year before BG was founded, Popular Mechanics published a cover story with their own future of transport. Can you guess what it is? If you were thinking flying car, you're wrong. Close, but not close enough. Popular Mechanics believed that in the future, everyone would have their own personal helicopter, small enough to fit in a garage but large enough for 2 people and groceries. A few years later, they would change this to a flying fan car. Built like a normal car with 4 powerful fans instead of wheels, it would fly much like a helicopter. Popular Mechanics believed this would be easier to fly than a personal helicopter and cost as much as a good car. Today, they might be a bit disappointed, but who knows? Give it a few more years. In the 18th edition, electric vehicle charging will feature prominently, outlining the requirements necessary for the installation of domestic charging points for these vehicles. These changes in this latest edition of the regulations are centred around the changing environment of the British automotive industry. While electric cars have been around for some time, it's only in recent years electric cars and other electric-powered vehicles have become common on the road, and we can expect to see more in the future. Currently, there are over 160,000 electric vehicles on UK roads, which is expected to grow to 165,000 new registrations in 2020. It is predicted by 2030 3 out of 5 cars will be electric. Now, with more electric vehicles on the road, there needs to be more charging ports and more are being bought. In 2017, 46,522 new plug-in hybrid cars were purchased by the British public. With this growing demand of electric vehicles, we are seeing the first generation of domestic electricians and installers installing charging ports for British homes. Prior to this, these installations were done by specialist contractors. With electric cars being more accessible, the same is happening with charging. These changes were made to Section 722 to provide guidance to domestic electricians and installers on how to safely install these charging ports. Regulation 722.411.4.1 concerns the use of protective multiple earthing in charging ports. Prior to the 18th edition, this would be all you need for earthing protection. As of January the 1st, this would not be the case and would require alternative earthing protection alongside protective multiple earthing. This could be a situation where a connecting point is supplied from a three-phase installation which is used to supply loads of other charging points sufficiently balanced between these points, or requires a very low-resistance earth electrode. This would mitigate the effects of an open circuit fault on the supply. There is also protection from a voltage-operated device which can be used in this situation. However, in this case, an earth electrode would still be a requirement for the device. For installing a charging port for a domestic property or a dwelling, one of these three requirements must be met. Another mandatory requirement is that charging ports must have a residual current device installed. What a residual current device would do is break an electrical current where there is a leakage. Detecting these leakages, they would disconnect and prevent potential harm from electric shocks. Part of the regulation 722.531.2.101 requires that charging ports have protection from residual current with both Type A and Type B devices. This would offer protection from residual fault currents. A Type A device, a single-phase rectifier, will alternate and/or pulsate detected residual current with DC components, making the charging port safe. A Type B device will detect residual current faults of AC current as well as DC residual current, a three-phase rectifier making the charging port safer. In terms of surge protection and the changes to Section 443, a surge protection device may be required depending on the location of the installation. If it is installed as part of a house, a dwelling, and close to the supply, the property's own surge protection would be sufficient. If the installation is far or remote from the supply, the same approach and requirements of surge protection apply. A risk assessment will need to be carried out, and, if a significant risk is found, a surge protection device will be needed. If not, it would not be required. Now, that is a lot of information to take in, and I'm sure you have questions. Let's look at arc fault detection devices first. Do I need to fit arc fault detection devices? This is only a recommendation in the latest BS 7671 18th edition. Is there a requirement to fit these in a particular environment? Unless a suitable evaluation of the risk has been carried out by one or more persons competent in fire risk assessment has stated the use of the devices is required. Can you test the device before fitting? Currently, there is no test equipment manufactured to test the function of an arc fault unit. Now, here are some frequently asked questions we've come across for surge protection detection in the 18th edition. What are Type 1, Type 2, or Type 3 surge protection devices? A Type 1 device is for service entrance power. These devices are recommended specifically for service sector and industrial buildings, protecting electrical installations against direct lightning strikes. Type 2 devices are whole home surge protectors. They are the main protection system for all low-voltage electrical installations. Installed in each switchboard, it prevents the spread of overvoltage in the electrical installations and protects the loads. Type 3 devices have a low-capacity discharge and are required to be installed as a supplement to a Type 2 surge protection device and in the vicinity of sensitive loads. Do I need to test these devices? If so, what are the testing requirements? No, the only way to test these devices would render them unusable. You can and should inspect the device before installing, looking at any potential damage to the device. Where are these placed in an enclosure? The Type 2 should be installed within the first meter of the incoming supply. Will any other devices do the same job? Unfortunately, no. Unlike other devices like RCBOs, which can do multiple jobs, there is no other device which can offer surge protection. Here are a few frequently asked questions concerning electric vehicle charging. What do the different modes mean? Mode 1, AC, is a domestic socket with direct connection. No protection device in cable. These are effectively obsolete due to safety concerns. Mode 2, AC, is a domestic socket and cables with a protection device for slow charging. For standard household socket outlets with an in-cable protection device and a power level control. Mode 3, AC, is a dedicated charger for fast charging, an EV socket outlet and plug with control and protection function. Mode 4, DC, are direct current DC connections for rapid recharging, a direct current with power levels starting at 50 kilowatts. What impact do they have on the consumer unit? These devices would require using an RCBO or MCB greater than the EV charger point, if already fitted with a safety device to prevent discrimination of devices. Thank you for watching BG Electrical's Introduction to the Wiring Regulations 18th edition. If you have further questions about the upcoming changes to the 18th edition, don't hesitate to ask. At BG Electrical, throughout its history, it's worked to meet the ever-changing demands of Britain's electrical industry. Developing and innovating, they've built a well-earned reputation for quality and excellence in its products. We have an extensive collection of surge protection devices, consumer units, and will soon offer efficient electrical vehicle charging. As British homes progress forward with better safety from electrical fires and the growth of electric vehicles in Britain, BG looks forward to playing a part of that future. Thanks for watching.